This is going to be a pretty basic example of how to find a point of inflection with a second derivative test, and also how to find where this function is concave up and where this function is concave down. So again, just like in the previous video, you'll start by finding the critical numbers for the second derivative, which is where the second derivative is 0 and where the second derivative is undefined. So let's go ahead and do the second derivative. It should be 6x plus 12. And this is never undefined because there's no denominators and nothing that would make this polynomial undefined. Polynomials are everywhere defined, so the second derivative is never undefined, but the second derivative is 0 when x equals -2. So that's going to go on our number line. That's our only critical number. This is again a y double prime number line. So we'll pick some numbers on both sides of -2, like 0, which is, we found out earlier, over here, and maybe -3. These are just easy old numbers. You can pick any number on this interval. There aren't any more critical numbers, so the sign will be the same on this entire interval. And the sign will be the same on this entire interval. That's why I just picked the easiest one. You could pick -10 if you wanted. Okay, so we're going to put these two red numbers in the second derivative. It's very important to put them in right here. So 6 times -3 is -18, and 12 is a negative number. I don't care necessarily what that number is, I just want the sign. And I'll put the 0 in here. 6 times 0 is 0, and 12 is a positive number. Okay, so just by looking at this number line, I can tell something about the function. So y is concave down on -infinity to -2. And that's because of this sign of the second derivative. This sign tells me that y is concave up on this entire interval. And this, since the second derivative is changing signs, this x equals -2 is a point of inflection at x equals -2. If you wanted to find this entire ordered pair, you'd say point of inflection at -2, and what's the y value? Well, you put your -2 in here and get a -8, and plus 12 plus 4, so that would be +8. So there's where my point of inflection is. And this is how I know I have a point of inflection, because my second derivative is changing signs. This is very similar to the y prime test for increasing, decreasing. If you had a number line that said y prime and the number line looked like this, you'd say increasing on this interval. Sorry, increasing on this interval down here, because this is positive. And if y prime is negative, you would say decreasing on this interval. So basically this part's the only part that changes. So that's it for concavity.